An instrument vibrate with a frequency of 1 Hz when there is no damping. No damping means natural frequency. So Fn equal to 1 Hz. From that, I can find out natural frequency in radian per second. Omega n equal to 2 pi f1. Standard formula. Frequency equal to omega divided by 2 pi. Then omega equal to 2 pi into Fn. Fn 1. So 2 pi into 1, 6.284 radian per second. This is the natural frequency. When the damping is provided, now we are providing damping, then the frequency was observed to be zero point 0.9 Hz, FD. Damped frequency equal to zero point 0.9 Hz. Now we can convert that omega d equal to 2 pi fd. Same formula. Only thing is instead of natural frequency, we are substituting damped frequency. Then substitute the value 2 pi into zero point 0.9. You will get 5.66 radian per second. Here we need to find damping factor. Damping factor means eta, not damping coefficient. Factor means ratio. Eta equal to C by CC. This is a factor ratio. Then logarithmic decrement L. So these are the two parameters we need to find. So there is a relation between omega d and omega n. That relation is omega d equal to omega n square root of 1 minus eta square. There is no need to memorize this formula. Natural frequency always greater than damped frequency, because the moment you provide damping, the frequency will decrease. So omega d equal to omega n times of some value. This value should be less than 1. Let's say omega d equal to zero point 0.5 times of omega n, zero point 0.6 times of omega n, zero point 0.7 times of omega n. Like that you will get. So when will you get less than 1 value? You have to subtract something from 1. So that's why I put 1 minus eta square. So only thing you have to remember is square root of 1 minus eta square. So this is a standard formula. Omega d equal to omega n square root of 1 minus eta square. Sometimes we will write omega n equal to omega d 1 minus eta square. This is wrong because omega d less than omega n, not omega n less than omega d. If you write like this, you will get different result. Then sometimes we will write omega n equal to omega d eta squared minus 1. This is also wrong. If you write like this, you will never get less than 1 value. This is some logic to find the exact formula. Omega d equal to omega n square root of 1 minus eta square. Now we can substitute omega d, omega n value here. Now I can easily find eta square. Here there is only one unknown, eta. We can easily find that. Apply square on both sides. So this will be cancelled. So now you can reduce this equation. You will get eta equal to 0.436. So this is damping factor, subdivision 1. Next, we need to find logarithmic decrement. There is a formula for logarithmic decrement. Del equal to 2 pi eta divided by square root of 1 minus eta square. We already know the value of eta. Just substitute the value of eta here in this formula. 2 pi multiplied by 0.436, that is an eta value, divided by square root of 1 minus 0.436. When you reduce this equation, you will get del equal to 3.04. So this is logarithmic decrement.